we'll discuss about IP version 4. IP version 4, IP version 6. There are two different addressing schemes in IP addressing. So IP version 4 is of 32 bits. That is, the address length is of 32 bits. Whereas in the case of IP version 6, it is of 128 bits. So the version updation in the IP addressing schemes gives a lot of features. As when you see IP version 4, we have some capabilities and we have some features for addressing the computers connected in the internet network. Whereas in the case, we do have some disadvantages, we do have some demerits, where the addressing of the network or the addressing of the computer is being more full, and those more sufficient number of addresses is not available for today's environment of data communication and networking. In the sense, like, large number of computers are grown up in the today's environment, and so we don't have a sufficient number of addressing available with the IP version 4, and so we actually progress into IP version 6. IP version 6 is a classless addressing schemes whose address is of 128 bits in length, and IP version 6 has more features as compared with that of IP version 4. Based on routing capabilities or based on the available number of addressing, IP version 6 is more commonly used nowadays. But first, let's discuss about the IP version 4 and then we can go for IP version 6. So IP version 4 addressing schemes, whereas this address is of 32 bits in length, usually represented in decimal notations. You might have seen the addresses like 10.0.0.1, which is assigned to your computer, or maybe like 192.128.1.1. So this is actually the IP address version 4, where we have a 32 bits in length. Say this is of 8 bits, this is of another 8 bits, and this is of another 8 bits, and the last is of another 8 bits. So totally it is of 32 bits IP address. And this IP version 4 addressing scheme is a classful addressing. It means it can be categorized into different classes. So class A, class B, class C, class D, and class E is the categorized IP version 4 address. First we'll discuss about the class A. To identify the particular address whether it belongs to class A, we need to check the very first bit. If the very first bit is equal to 0, then it belongs to class A address. In class A address, or in any address in IP version 4, we have two parts in the address. One is the network part and the other one is the host part. There we have a network ID. That means assigning an address for the network in the internet. And host ID is the end device which is being connected with the internet will be assigned an address. So whenever we wanted to send the data, we are supposed to mention the address of those end devices to whom which the data has to be delivered. So in this case, class A, if the very first bit is 0 and the next 7 bit is going to be representing the net ID. As we all know that the net ID, in a sense, like 2 power 7, that is equal to 128 addresses, right? Out of this 128 addresses, you know, 0th address and 127th address will be kept reserved for some future. And so this 126, I mean, like excluding 0th address and 127th address, the remaining 126 address can be used for addressing 126 networks. And look at this part. This is actually host part, that is the end devices. How many number of end devices can be connected to each of the network. So here 2 power 24 number of host computers can be connected, that is end devices can be connected with each of the network. So in class A, if you find the address, I mean, like if you convert this 10.0.0.1 to a binary number, and if you see very first bit is going to be the 0, then it belongs to class A. So the remaining 7 bits, the next 7 bits is going to represent the network ID, and the remaining last 24 bits is going to represent the host ID. So as I told you, 2 power 27 networks can be addressed. In this case, 2 power 24 host computers can be addressed with the class A address, class A addressing schemes. Now we have a scenario like in a network, in a globally, when you take the world, globally where we have internet connections and you have a large organizations which requires some more number of networks. Say for example, if they need more than 128 networks to be assigned with an address in their organization, this class A address is not sufficient, right? So because it can address only 128 networks, not more than that. So in that case, we are supposed to go for class B addressing schemes. So to identify whether this address belongs to class B, we need to check the very first bit. If the very first bit is 1, you have to check the second bit, and if the second bit is 0, then it means it is class B addressing scheme. So the remaining 14 bit is network ID and the remaining 16 bit is host ID. So in this case, this host ID, that is this network ID and the host ID is the one, like, 2 power 14 number of network IDs networks can be addressed, whereas in this case 2 power 16 host computers can be addressed with the network, right? So then we go for class C. In case if you wanted to find out what this address belongs to, whether it belongs to a class C or class B or class C, as I told you, in class C you have to check the very first bit. If the first bit is 1 and if the second bit is 1 and if the third bit is 0, then it means this address belongs to class C addressing scheme. And the remaining 21 bits is going to be representing the network ID, and the last 8 bit is going to represent the host ID. So as I told you, for network ID, 2 power 21 networks can be addressed with the class C. It means large number of networks can be addressed, but with each of these networks you can assign an address for some 2 power 8 computers. That is, only 256 n devices can be connected with each of these networks. So that is the case of a class C address. So when you take a college where they have some 5 departments, so they're going to have some 5 different networks. Only 5 different networks are there, and the n devices in each of this department may be of 60 computers. So if they prefer to use the class C, you imagine how many number of addresses wasted. Like 2 power 21 networks can be addressed, but what we are doing is we are just assigning the network ID for only 5 networks. And 8 bit, 2 power 8 is equal to 256, right? So in that case, 256 n devices can be connected, but what we do is we connect only 60 computers with each of this network. So how much amount of addresses is wasted, right? So then we do class D. We can see this class D addressing scheme. Class D addressing scheme is used for multicasting purposes, where multicasting is the part where you have one source who actually generates the data, and the data is about to be transmitted or sent to different host computers connected in the internet who belongs to a group. We can say the group name is going to be G. So every user, every host computer who belongs to a group called as G will receive this multicasting informations. So the source computer will have a unique way of addressing for multicasting transmission. So that is this, where the first bit is going to be 1, second bit is going to be 1, third bit is going to be 1, and the fourth bit is going to be 0. And this is actually representing the multicast address, which can be used for transmitting the data to group members who are connected globally in the internet network. And the last one is class C addressing schemes, which is actually used for future purpose. It is actually reserved for future purpose, or can be used for some scientific research, and it is not used nowadays. And as I told you, the insufficient or the inefficient way of using the address for the networks or the host computers, that makes this Ipv4 address to get it is already over. There is no more enough addresses for assigning the networks globally in the world. So in that case, we migrate from Ipv4 towards Ipv6, whereas in the case of Ipv6, we do not have this kind of a network ID or host ID. We do not have any kind of a class A, class B, class C, class D. It is completely a classless addressing, where the address length is going to be of 128 bits, where this Ipv6 addressing schemes will have advanced routing capabilities as compared with that of the Ipv4, and it has more added feature, and that makes it more comfort for the network administrators to assign the addresses for different networks and different host computers connected in the network.